Today we're going to go over the concept of increasing, decreasing, and constant functions. A function is increasing on any interval in which its derivative is greater than 0. It is decreasing on any interval in which its derivative is less than 0, and it's constant anywhere where f prime of x, the derivative, is equal to 0. Okay, I'm going to draw a graph. Let's suppose we have a function whose graph looks like this. Goes up, goes down, and goes up. So this particular function goes up between a and b, so that means it's increasing between a and b. Between b and c, the graph drops, so it's decreasing. After c, the graph increases, so the function is increasing. Let's do some examples. For example, suppose you have a function like this. F of x equals minus 2x cubed plus 54x minus 14. And they want to know what are the intervals in which the function is increasing and what are the intervals in which the function is decreasing. So we need to find the derivative and figure out where is the derivative positive and where it's negative. The derivative of this function is minus 6x squared plus 54. Well, let's set this equal to 0 by factoring it first. Take out minus 6, so that gives you minus 6x squared minus 9, and then factor out x squared minus 9. And we need to figure out where is this equal to 0. Sometimes we don't have to, but this time we do. So x plus 3 equals 0 when x equals negative 3. And then x minus 3 equals 0 when x equals plus 3. So the two critical numbers are x equals minus 3 and x equals 3. Okay, let's put them on the number line, minus 3, 3. And we have 1, 2, 3 intervals. We need to check the sign of the derivative in each of these 3 intervals by picking test points. A test point is any point in the interval. So for example, between minus 3 and 3, I can pick x equals 0. I can pick x equals 1, 2, any number. Between minus 3 and minus infinity, I'll pick x equals minus 4. And then between 3 and infinity, you can pick x equals 4000 if you wish, but I'm going to pick x equals plus 4. Substitute each of these values of x in the derivative right there. So for x equals 0, when you put 0 there, minus 6 times 0 plus 54 will give you a positive. Substitute minus 4 there, and you'll end up with this. Negative 6 times negative 4 squared plus 54. And this will be a negative. Substitute 4 in there, and you'll end up with minus 6 times 4 squared plus 54. This will also be a negative. So these are my test points. Now, where the derivative is negative, the function decreases. Where the derivative is positive, the function increases. So the answer to the question is decreasing on minus infinity to minus 3. Increasing between minus 3 and plus 3. Decreasing between plus 3 and plus infinity. Decreasing, increasing, decreasing. All of these intervals are open, so we must use parentheses, not brackets. And that's how you find the intervals in which a function increases and where a function decreases. Let's do another example. Let's do this example. F of x equals x cubed minus 9x squared plus 24x minus 17. Well, we need to find the derivative first. F prime of x is 3x squared minus 18x plus 24. Let us factor out a 3. So 3 times x squared minus 6x plus 8 equals 0. Divide both sides by 3, so we don't have to deal with this 3. Factor this, and it gives you x minus 2, x minus 4 equals 0. So x equals 2 and x equals 4. Those are special points. They could be critical numbers. Okay, here's the number line. X equals 2, x equals 4. Now we have 3 regions, 3 intervals, in which we need to pick test points. So we need to pick a point to the left of 2. I'm picking x equals 0. We need to pick one between 2 and 3. I'm picking x equals 3. And one greater than 4. I'm picking x equals 5. Okay. Substitute 0 in the derivative. 0 minus 0 plus 24. Remember, always substitute in the original. In case you had divided by a negative and you substitute in the simplified version, you will end up with the incorrect signs. So always substitute there in the original derivative. So when you substitute 0 here, you get a positive. Substitute 3. So 3 times 3 squared minus 18 times 3 plus 24 is a negative. Substitute 5. 3 times 5 squared minus 18 times 5 plus 24 is a positive. So positive, negative, positive. So the function increases in this interval, increases on minus infinity to 2, decreases between 2 and 4, and increases again between 4 and plus infinity. And again, all the intervals must be open. So increases, decreases, increases. Two or three. The function is f of x equals 3x to the fourth minus 96x plus 1. The derivative is 12x cubed minus 96. We need to divide this by 12 so we can set it equal to 0. Divide this by 12. And that gives us x cubed minus 8. Okay, you might wonder, x cubed minus 8 equals 0. Why don't we just take the 8 over to this side? So that gives us x cubed equals 8. X equals 2, and we're done. We could be, but we want to make sure that there aren't 3 real solutions. So what we do with x cubed minus 8, we factor it. This is how we factor it. This part has no real solutions. So therefore, the only solution is indeed x equals 2. So this way it would have given us the correct solution, but we still need to make sure that there are no other solutions. Okay, so x equals 2 minus infinity plus infinity. Now we only need to pick 2 test points. I'm picking x equals 0 and x equals 3 as my test points. 0 is to the left of 2. Put 0 in the original derivative. So 0 minus 96 is negative. Put 3 in the original derivative. 12 times 3 cubed minus 96 is a positive. So the function decreases between minus infinity and 2, and it increases on 2 to plus infinity.